Hello everyone, welcome back to my YouTube channel. I'm Rishi, and today we are at chapter 3, form 1, squares, square roots, cubes and cube roots. This is the first part of a two-part video series, and in this part we will be going through all of the concepts and the things you must know before starting to answer questions regarding chapter 3. Without any further ado, let's begin. This chapter might be my most favorite chapter of all time. I think I've said that before, but still, this one takes the throne as my favorite chapter of all time. It's mainly because of how simple it is to understand. But don't worry, we will be going through each one of these terms one by one. So as you can see, the title itself says squares, square roots, cubes and cube roots. So let's start with the first one, squares. So what is squares? So squares, by the word itself, you can know that they're referring to a square. So what they're trying to do is, the concept of square is, you times the sides to get the area of this particular shape. So the area of this square will be x squared. By the way, this is called squared. Okay. So if someone asks you 3 squared, what you can do is visualize a square and then assume that the side of the square is 3 centimeters, or 3, just 3. Then if one side is 3, the other side must also be 3. So just find the area of the square. You will get 3 squared, which is 3 times 3, which is 9. So with that connection, we can straight away write down as anything. For example, x squared means x times x. That's it. This 2 refers to 2 x's, first x and second x, multiplying together. That's it. That is squares. So let's have some fun here. 5 squared is, your turn, come on. Yes, 25, because it is 5 times 5. Alright, next number. 9 squared is, take your time. Yes, correct, it is 81. 9 times 9. Let's go a bit harder. 20 squared. I know some of you got it. It is 400, because we just take 20 times 20. What about 25 squared? For those who have been following the channel, you would have known that there is a video in Mental Metric series where I posted on how to square numbers faster. So if you are interested, just go and take a look. It's in my channel. It's a fun way to do mathematics. That's why this chapter is one of my favorite chapters, because there are lots and lots of tricks involved. 25 squared is 625. Alright, that is squared. Now, the next part is square root. But before we go from square to square root, there's something that is known as perfect square. So perfect square refers to any square number that can be divided into 2 parts. Okay, that is a bit confusing. So for example, let's have a number. 3 squared equals to 9. Okay, 3 squared equals to 9. So in this scenario, this 9 is regarded as a perfect square. So how I remember it is as perfect square's area. Alright, this area part is not used widely. It's just the way I used to memorize or to understand. So perfect square's area means there is a square which is area 9. So if it is possible for a square to have the area of 9, because 3 times 3. Do you see that? It's possible. It is possible. If the number is 8 and we asked to find x, can you actually find it? Because if you were to draw a square and regard 8 as the area of the square, it is not possible, because no number times by itself will no integer times by itself will give you 8. Of course, if you square root 8, there will be some kind of weird numbers, but as a whole number, there is no number that can multiply itself to get you 8. So perfect square refers to a number that is the product of a whole number squaring itself. Okay, so for instance, if we have 4 squared, 16, so correct, 16 is a perfect square. So as from what we will see from the next part, perfect squares are numbers when you square root the numbers, you will get a whole number as an answer. Okay, so with that out of the way, perfect square, let's go to square root. So square root is the inverse of square. Just like how we have times and divide, both are opposites, and plus and minus, we also have something for square, which is root, square root. If it is 3, we call it cube, and it will become cube root. So it's just root, essentially root. So for a to become a square, we call it squaring. That means a different color. I hope you like blue. Squaring. And then for a squared to become a, we will square root. So the symbol for square root would be this. It's some way between a divide, you know, the old school divide that we have, and with this leg behind. Yeah, I think you understand the gist of it. I don't want to describe it. It's kind of difficult to describe the picture. Okay, so that is root. And for information, for square root, there is no 2 here. There is no need for a 2 here. But as you go higher, for 3, 4, 5, 6, you have to write 3 or 4 there if the question requires. But for 2, for square, there is no need to write this, because it's understood that if there is no numbers, it's gonna be square root. Okay, square root 16. So since we have established that 4 squared equals to 16, it is safe to say that the square root of 16 is 4. That's it. But if it's an easy number like 16 is possible to see how it works. But what if you get a difficult number? So when you get difficult numbers, which they're asking you whether it's possible to be square rooted or is it a perfect square, what you can do is, for example, you have 81. So how do you make 81 in how do you check whether 81 is a perfect square or not? Whether when it is square rooted, you will get a number that is whole number. I'm still not sure whether square rooted is a word or not, but for the sake of this video, we will just use the word square rooted. Okay, so 81. So we go simple. Let's go simple. So what's the smallest number that can divide 81? 3. So 3 times what gets you 81? So 27. 27 times 3 gets you 81. Okay, let's break it down further. 3, 27. So what can you do? 27 broken down. What's the smallest number that can divide 27? Which is again 3. Then we have 9 here. So again, let's break down 9. You will have 3 and 3. So if you take a closer look, you will start to see that you have 3 times 3 times 3 is equals to 81. Here, you have to know, you have to be alert that this particular question is asking whether 81 is a perfect square or not. So for a perfect square, you will have two same numbers multiplying each other. So what is common in this method is you have to separate the numbers that are multiplying each other into two sections. So if we have 4 and all of them are identical, so we can just break them into 1 and 2. So if you see closely, you will get 9 times 9 equals to 81, which can also be written as 9 squared equals to 81. So the moral of the story is the square root of 81 is 9. That's it. As simple as that. Let that sink in. Okay. If you were not able to understand this whole process, I would recommend you to watch it one more time. Just one more time and you will get it. You will get it. No worries. Alright? So let's move on to the next part. We're done with square, perfect squares, and square roots. Now it's time to take a look at cubes. So cubes is just exactly the same thing as squares. Well, not the same thing. Similar concept. So for square, we had, square. For cube, we're gonna have cube. Don't know why I'm doing this. I'm saying the exact same thing twice. So we are gonna have a cube. I have a cube. So when someone says, when the question, well, no one will say, but when the question asks you to find 3 cubed, what you do is you assume that the length of one side of the cube is 3, and you would just find the volume. So what you do is you take 3 times 3 times 3. So you have 3 here, and you're going to times 3 times by itself. 3 times 3 times 3, you will end up with the answer 27. That's it. So cubes are as simple as that. So let's go a bit easier. For example, if I ask you 2 cubed, what's the answer? Take your time. It's 3 numbers, I know. Take your time. Okay. 5, 4, 3, 2, 1. So 2 cubed is essentially 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. That's it. As simple as that. Let's go a bit harder. 5 cubed. 5 times 5 times 5. I think we may need a calculator here. Okay. So the answer is 125. Give yourself a round of applause if you have got it. If you got it. Pardon my English. Alright. Now we are done with cubes. So same as squares, there are perfect squares, also there are perfect cubes. Same concept, perfect cubes are cubes when cube rooted, they will give you a whole number. So perfect cubes, the first way to find them is just cube a number. For example, we had 5 cubed earlier. So 1 to 5 is a typical example for perfect cubes. Because when you cube root 1 to 5, you will get a whole number, which is 5 in this case. Alright. So if you were to find whether a number is a perfect cube or not, you can also use the same method we used earlier. So for example, let me give you 7 to 9. So 7 to 9 is a big number, but since we know that 72 is divisible by 3 and 9 is divisible by 3, let's just use 3. 7 to 9 divided by 3, then we will have 2, 4, 3. If you want to use a calculator, feel free. There is no competition here. It's completely fine. So again, the smallest number is 3 divided by 3, you will have 81. So we already did 81, so let's just fast forward. We have 3, 27, 3, 9, and 3, 3. So at the end of it, you will start to see that you have 1, 2, 3, 4, 5, 6. You have 6 trees. So by 6 trees, I mean you have 3 6 times. So 3 times 3 times 3 times 3 times 3 times 3. I may not follow the grid because, you know, there's not much space to work with. So we have 6 trees here, which when multiplied together will give you 81. All right. Now, earlier for squares, we know that it's two numbers multiplied with each other. So we separated these numbers at the top into two parts. But here, this is cube. So cube means it involves three same numbers. So we are going to separate these 6 numbers into 3 different parts. So we will have 1, 2, and 3. Make sure they're identical. We have 3 here, so it's identical. 3, 3, 3. If it is something else, make sure you group them into identical parts. But the rule must follow. For squares, it has to be into 2 parts, and for cube, it has to be in 3 parts. All right. So here you have 9 times 9 times 9, which is 729. Oh man, I made a mistake. This is not 81. Sorry, I kind of forgot that we were doing 729 and I just stick with 81. Sorry. There's a redo here. It's 729. Alright. Pardon my mistake there. Let's move on. 9 times 9 times 9 is equivalent to 729. This 9 times 9 times 9 can be written as 9 cubed equals to 729. So the moral of this story will be the square root of 729, not the square, pardon me, the cube root of 729 is 9. That's about it. So this is perfect cubes. So let me briefly go through cube roots, because at this point you have already understood how roots work. So cube roots will be exactly the same. I don't think I have to go through cube roots again because it's exactly the same as this. So perfect cubes and cube roots kind of go hand in hand, because for a number to be a perfect cube, it has to be able to be cube rooted, and you must get a whole number. And that's it for the understanding part. Now, for this chapter, apart from me just explaining it to you, it's important that you play around with your calculator. Seriously, trust me. For this chapter, you don't have to do a bunch of questions. Although it might help, it will help a lot. But my first suggestion is, if you want to understand it first, just play with your calculator. Do 7 times 7 and then do 7 squared, and then the answer will be same. I know it might look childish, but trust me, if you just spend a few minutes playing with the calculator, you will kind of get a feel for this chapter. And when you get the feel for this chapter, that's all you need to understand everything. So my first suggestion, go and play with your calculator. Use square function, use cube function, use square root, use cube root, and see how they relate to times and divide. And just have fun with it. No worries. In this chapter, we are going through squares and cubes. As you progress to form 2 and form 3, you will start to see bigger numbers. There will be to the power of 4, power of 5. But that's a story for another day and another video. And in the next part of this series, we will be going through the questions and how to tackle them. As usual, thanks for watching, and I will see you in the next one. Till then, bye-bye.